If the power series given by this expression converges for mod x is less than x and diverges for mod x greater than c, then the value of c correct up to 3 decimal place we have to find out. As you can see, converges for mod x less than c, this is nothing but c is radius of convergence, because power series converges for those values which are less than radius of convergence and diverges for greater values of radius. So we have to find the radius of convergence this power series, because this power series is not in a standard format as un x raised to the power n, or around a point as un x minus a raised to the power n type. If power series is given in this format, so we can easily find the radius of convergence by un upon un plus 1, and this is the radius of convergence, and we take this power series converges for mod x less than r, or we can say diverges for mod x is greater than r. For equality we have to investigate further, but whenever power series is not in a standard format, then you can consider this as an, and we have to find the limit of an upon an plus 1, and we need to take a more absolute, because of sometimes power series may be alternative positive or negative. So limit n tends to infinity, which is the radius of this power series. And when radius is we can easily find, then because this is not in standard format as x raised to the power 2 in type, so either you can consider or replace x raised to the power 2n by z, or x square by z. So that will help you in understand better. So this will be the radius of convergence, but when we are trying to find interval of convergence, keep remember interval of convergence x square less than r, this power set will converge for x square, because of this can be written as x square raised to the power n. That will be the standard format when x square is replaced by z, and diverges for x square or mod of x square is greater than, we have to take mod of this also. So find radius of convergence r by is given n factorial divided by n raised to the power n. This is my an, and need to take n plus 1 raised to the power n plus 1 divided by n plus 1 factorial. So this one cancel out, and we will have n plus 1. Also we need to take n raised to the power, and limit n tends to infinity. So this implies that r equal to limit n tends to infinity. So n raised to the power n plus 1, 1 plus 1 upon n, and this is n plus 1 divided by n raised to the power n. So it will cancel out by this one, and we have the value n. So expression we have r equal to limit n tends to infinity n, and within bracket this is n plus 1. Also this one can be written as limit n tends to infinity n, 1 plus 1 upon n, and 1 plus 1 upon n raised to the power n. So limit of this one will be 1, and limit of this one will be e, and this is I did some mistake, I think n plus 1 raised to the power n plus 1 and factorial It is okay. Also n plus 1 is left in the denominator also, so you have to write n plus 1 in denominator. So n plus 1, and you need to take n as a common, so this one will cancel out and we have 1 upon n. So this limit will be n tends to 0, 1 plus 1 upon n, and 1 plus 1 upon n raised to the power n divided by 1 plus 1 upon n. So limit of this expression we have is e. So radius of convergence is r, is e, and we have the value of e is 2.718, because we have to tell the radius of convergence or value of c in terms of 3 decimal place. So this power series will converge whenever x square is less than, mod of x square is less than e, or and diverges, it is convergent, and divergent for x square is greater than e. So it will converge for x square is less than mod e, square root of e, and whenever you will find the value of this, so it will come out by, because 2 point something, so 1.3 or some other values you can find, because of in exam module there will be a scientific calculator, so you can easily find the value of c. But I have told you what is the process to find the value of this one, so it is not tedious or harder to solve any one.